Hi, I'm Paul Smitherman, and this video is a digital preservation demonstration. We'll be looking at two digital preservation processes in an end-to-end scenario, from obtaining an image of the bitstream on a nearly 30-year-old floppy disk to ingesting that image into a digital preservation system. The 5¼ inch floppy disk was ubiquitous in the 1980s and early 90s. In those years, hard drives were very expensive, and many people used only floppy disks for storage. We sometimes find these disks in boxes of papers of professors, writers, politicians, and others. Occasionally we get a request to find out what is on the disk. That's where the process begins. This is a typical 5¼ inch floppy drive. What we want to do is make an exact image of the bitstream encoded on the disk. To do that, we use a special interface that takes the bitstream from the disk through a USB port and produces an exact image of the disk on our modern computer. The interface is made by a company called Cryoflux. I've got a floppy disk here, and I'm going to go ahead and put it into the drive. Now we can start up the Cryoflux software and transfer the bitstream. Here's the Cryoflux application. It's written in Java and it works quite well. I'm just going to check the output directory. I'm using this BitCurator shared folder. We'll be moving the disk image from the shared folder into a virtual machine running Linux to use the BitCurator software. We just need to give the image a name, and then we're ready to start the read process. Looks like we're underway here. The grids at the top show that Cryoflux is reading the disk sector by sector. The disk has data on two sides, and you can see the sectors being read from both sides of the disk. The sector blocks are color-coded. Green means a good read. The H's at the top are the header section of the disk. Looks like the system has finished reading. I'll go ahead and double-check that the image file is in the output folder. You can see here that it is, with the file extension .img. This is the exact image of the bitstream encoded on the disk. So how do we look at what's on the image? I'm going to access the image with a forensic tool in the BitCurator suite of tools. BitCurator is a Linux distribution with the BitCurator tools installed on it. To use it on my PC, I'm going to run it on a virtual machine using VirtualBox. So here we are at the VirtualBox start page. I've got 3 different virtual machines installed here. I'm going to go ahead and start up BitCurator. And now BitCurator is up and running. I'm going to open up the folder with the forensic tools. We're going to use the Disk Image Access tool. We'll go to that folder that is shared between Windows and this virtual Linux machine, and open our disk image. When we open the volume, we can see the files that were on the disk. We'll select them and then export. We'll put the files in this folder I created in the shared folder. And double checking, the files are in there. A lot of these old files we find are correspondence, reports, and the like. The word processing programs they were created with typically put formatting codes in the file. They are generally readable if you open them in Notepad or some other text editor. There were 2 disks in this set, and on the other disk, whoever put the files on the disks also put a copy of a word processing program called Professional Write. I couldn't get Windows 10 to run this software, so we're going to use emulation via Windows XP and VirtualBox. We've got Windows XP going, and we'll go ahead and look in the shared folder. I've got the files from the disk image and also the Professional Write software. Here's the Professional Write application. This word processor appears to be dated 1986. It's a DOS program, so we can only use keystrokes. Navigating through the directories, we select a file and open it. This appears to be an agenda for a meeting in 1990. Rather boring, but it is interesting to see the document in the original application that it was created in. We can also open it in a text editor like Notepad. There's really no formatting codes here, but some documents were heavily formatted, making it more difficult to read the text. Now we'll switch over to Archive-O-Matica. Archive-O-Matica is a free and open-source digital preservation system that is designed to maintain standards-based, long-term access to collections of digital objects. The first step is the transfer. Here we move digital objects from wherever they are stored onto the Archive-O-Matica platform. We can search for objects in places that we have designated for transfer. For a number of reasons, I'm using the online demo version of Archive-O-Matica, which doesn't allow users to import their own objects. I'll instead use a disk image from the sample objects provided. Let's use this ISO disk image. We select it and then add it to the transfer. We need to give the transfer a name and start the transfer. Archive-O-Matica archives digital objects with processes called microservices. Rather than running one long continuous process, the system uses small processes, giving the user much greater control over the archival process. By default, some microservices request approval before continuing, and the microservices may be configured in many ways depending on the preservation job at hand. Here you can see the microservices running. This microservice has stopped and is asking if I want to normalize. I'm going to say no because we're using a disk image. The output of this process is an Archival Information Package, or AIP. Here the system has prepared a METS document to accompany the AIP. Finally, the AIP is stored. I've located the AIP in the archival storage location. I'll download it and we can take a look. The AIP is a compressed 7-zip file, so we need to extract the contents. Looking into the data folder, we can see the METS document. Looking at the objects folder, we see our ISO image object. The last thing to look at is the METS document. You can see here the header, the descriptive metadata section, the administrative metadata section, which is quite long, the file section. Here you can see our single disk image, and the structural map. There are no structural link or behavior sections. I hope you enjoyed this walk through some of the many digital preservation processes. Thanks for watching.